So the objective today is to interpret unusual answers when solving equations. The algebra book that you guys are working out of doesn't emphasize this. It does show up, but in the Math 8 standards, it's huge, this idea. In fact, every single question that I found on Illuminate came from this perspective. So that's how important this notion is. So basically, what they're going to do is give you lots of equations to solve and then ask you a crucial question. How many of these equations had exactly one answer? And then but you'd have to solve through all of them to figure out which ones had exactly one answer. And that's pretty much all you guys have worked on, are equations that have exactly one answer. Kylie.
Oh, are we teaching the test on
I already made that announcement. Okay. So let's go and revisit the kind of question that you guys have been seeing. So there's actually 3 possible solutions when you're solving an equation in one variable. Okay? And you've only dealt with one of them, so let's review that. Directions are going to tell you to solve. And we've got 4x minus 3 equals 2x plus 13. All right, so what's the first step? How? Do we have any like terms on the left or on the right? No. Do we have any parentheses? No. So what we're about ready to do is opposite. We're going to go opposite sides, okay? So what are we going to start with?
Subtract 2x.
Yeah, we want to get the variables on the left, so opposite would be subtracting 2x from both sides. That gives me 2x minus 3 equals 13. Then what?
Add 3.
Not plus 13.
Add 3
We need to add 3 to both sides to get all the constants on the right. And we get 2x equals 16. And then we're left, what do we have to do, though, to get x equals 8? We've got to divide both sides by 2. That's called justifying your solution. So we get x equals 8. So it says, in order for 4x minus 3 to be equal to 2x plus 13, x can only have one exact value, and that exact value is 8. Okay? So that's the kind of questions you've seen over and over and over again, is like that. All right, let me pause this. All right, so here comes the second equation. 4x minus 5 equals 2 times the quantity 2x minus 1, all of that minus 3. All right, so am I ready to do opposite operations already? No, I got some parentheses. I'm going to have to deal with that first. So on the left side, nothing's going to change because I can't simplify 4x and 5. So what I am going to do, though, is distribute. So I get 2 times 2x gives me 4x. And here's, one of the biggest problems we've noticed is not understanding the process. It's making calculation errors. It's making sign errors. 2 times a negative 1 is going to give me a negative 2, so we just write minus 2. Now the negative 3 was on the outside of the parentheses, so I'm not going to distribute to it. Am I set to go on the right side? Now if you notice, I got 3 terms, and so we always need to simplify those terms. So we still have the 4x minus 5 equals 4x, and then we're going to combine up these two, and the signs are the same, so I'm going to add, and the answer is going to have the same sign, and I get 4x minus 5. So I've simplified each side of the equation, and now I'm ready to take variables to the left. So when I subtract 4x from both sides, if you hadn't noticed it already, something completely strange happens. The variable has been completely eliminated out of the equation. So now what we have to do is look at that answer, and we need to interpret it. So we have to ask ourselves a question. And the question goes like this. When does negative 5 equal negative 5? When does that happen?
When it's multiplied by
When does negative 5 equal negative 5? Justin?
Variables one.
Okay. This is a real simple answer I'm looking for. Okay, whoever's got the laser, is that you, Anthony? Is that you with the laser? Okay, you're not supposed to have a laser? Well, if you've got a laser that's coming out of your pen, you need to not have it. Okay, well, somebody's got a laser going, so I'm going to ask you not to use it because that's very damaging. You've already used it once up here and was once in the back. So please don't play with that. Okay? Okay, Anthony, you can stop. Okay, Kyler,
negative 5 minus 0.
hold on. Question is, when does negative 5 equal negative 5? I heard it. Always. Negative 5 always equals negative 5. So the answer is always.
That's it.
Okay? When we get an answer that's always, this is what we write for our solution. There's all real numbers. In other words, the variables will always cancel each other out in this problem, so it doesn't matter what I plug in for the x value. I'm going to get what's on the left is going to equal what's on the right. In fact, if you look back here, when we finished simplifying, I had an equation that was equal to itself. So anytime I get an answer that's always true, it always is going to happen, I can say all real numbers. Now, the book adds a different label to it, so I want you to know what that label is. They call it infinitely many solutions. So my thought is, if they are using this terminology here, then they're going to use it on the SBAC, and they're going to use it on any questions we get that are SBAC-like questions. So you need to understand this means infinitely many solutions. Now, I'm going to tell you why I have a little bit of a beef with this answer, but again, I can't go against what the publishers are doing, so we're going to have to keep this language the same. So these two mean exactly the same. Now, we've always said all real numbers when it's been a single number going in. So what number could I put in for x and get something that's true? Any number.
Z.
So it could be positives, it could be negatives, it could be fractions, it could be decimals, it could be whole numbers. Any number is going to make this equation true. When I use the label infinitely many solutions, that for me, for all the years that I've taught algebra, always meant it's an ordered pair, which is a combination of two numbers that actually identify the location of a point that is the solution. So that's where I'm a little confused, because infinitely many solutions always indicates to me an ordered pair, but now with Common Core, that means that all numbers work. Okay? So we're going to be using this one because that's what you're going to be seeing in your homework. You're going to see that on the tests. Okay, so infinitely many solutions. So that says any number will work. But the way to appropriately say any number will work is infinitely many solutions. Taylor, you had a question. Okay. Yeah, so we don't get the luxury of saying all real numbers, and which is a bummer because there was actually a symbol that we could have used to mean all real numbers. We don't have a symbol for this one. Okay. All right, so let's try one more. What else do you think might be a situation that arises now that you've experienced, we got exactly one answer, we have an infinite number of answers? What do you think could be another one, Joe?
So any number that will work can be correct.
Yeah, so what you have to, so instead of picking any number and saying this should work, you have to give this answer. You have to say infinitely many solutions. When you solve and you get to a point where what's on the left is identical to what's on the right, and that's always true, then your answer is infinitely many solutions. Okay? So you actually stop work once you notice that relationship exists, and you write infinitely many solutions. Okay? So, anybody have a guess what our third choice is going to be for types of solutions we're going to get? Repeating would be the same answer over and over again, so that would be still one answer, right? So we've already covered that. Anybody else? That's a number, so that works. All right, let's try this one then. See if you can discover it. So we've got 4x plus 2 equals 4x minus 5. So notice that this one's really a nice equation. There's no parentheses. There's no 3 or more terms on a side. There's no combining like terms. There's no simplifying that needs to do. I can actually just launch into the solving process. So I start with my variables. And when I subtract 4x from both sides, I end up getting 2 equals negative 5. So again, the variable's completely eliminated. But this time, I didn't have the same number on both sides of the equal. I have a different number. So you ask yourself this question. When does 2 equal negative 5? And your answer is going to be never. What this is saying, how we interpret that, means it doesn't matter what I put in for x, I will never get something that's what's on the left is equal to what's on the right. So there is no solution. So the n for never gives us the answer of no solution. Okay. Now that one I do have a symbol for. So you can either write the words out, no solution, or you can use the symbol, which is a 0 with a slash. It has to be a diagonal slash, not through the center, because then that means theta, which is a Greek letter, and people get confused. So this means no solution, okay? So you can use anything. So here's what's kind of funny. I mean, we can experiment with this. So let's go back and just prove out why there's no solution. So if I took the number, let's say 1, and plugged it in for x, wherever it showed up, and solved out the equation, what I get is 4 plus 2 equals 4 minus 5. And I get 6, wait a second, that doesn't equal negative 1. So that's what happens with these problems where there's no solution, is it doesn't matter what you substitute in for that x, you're never going to get an answer that works. So here's the bummer with now making this part of what you have to work on, is that you can make careless errors and get something that looks like there's no solution. But in reality, there is. So that's where we have to be super cautious and very observant when we're doing our homework to make sure that we're not going to have false answers, okay? So if you want to just look back at this one here, we could plug in a number. Let's plug in 1 for this one as well, and you can see what happens. So we get 4 times 1 minus 5 equals 2 times the quantity, 2 times 1, and then let's see, that minus 1 minus 3. So I get 4 times 1 is 4 minus 5. Over here I get 2, and in the parentheses 2 times 1 is 2. 2 take away 1 is 1. 4 take away 5 is negative 1. And I get 2 take away 3. And that gives me negative 1 equals negative 1. That's true. So 1 works. The reality is I could try for the rest of my life every single number I could think of, and they're all going to work in that one. That's when we have to be reasonable when we see, oh, those two numbers are equal to each other always. So then that's why I'm going to choose infinitely many solutions. So for me, I always tied in always with all real numbers was an easy memory for me, but now it's infinitely many. Giovanni, you put the one I circled, infinitely many solutions, because that's the one that they wrote in the standard, okay? Now, we're also going to study something called a system, where we're going to put 2 equations together, and your job is to figure out what they have in common, but that solution is going to be an ordered pair, okay? So we'll get into that later. All right. Everybody good?